The National Electrical Code, specifically Section 110.26C2, addresses working space and access to electrical equipment. This section has specific requirements for large equipment, and until 2005, it pertained to equipment rated at 1200 amps or more. The key question here is whether a large panel, rated for 1200 amps but equipped with a smaller main breaker such as a 1000 amp ground fault protective equipment or GFPE main breaker, necessitates having two doors and panic hardware. The answer is no. The determining factor for the two-door and panic hardware requirement is not simply the panel's rated amperage. It depends on the actual overcurrent device installed. Even though the panel itself is rated for 1200 amps, the presence of a 1000 amp breaker means that the requirements for equipment rated 1200 amps or higher do not apply in this specific case. To understand this better, let's break down the relevant parts of the National Electrical Code and the underlying principles. Section 110.26 of the National Electrical Code deals with the space around electrical equipment. It specifies the working space required for personnel to safely operate and maintain electrical equipment. This working space includes minimum clearances in front of the equipment, as well as the width and height of the working space. The specific dimensions depend on the voltage to ground and the condition of the installation. Condition 1 refers to exposed live parts on one side and grounded parts on the other side of the working space, requiring a certain minimum clearance. Condition 2 refers to exposed live parts on both sides of the working space, necessitating a greater minimum clearance. Condition 3 involves exposed live parts on one side and grounded parts on the other side with insulated or guarded parts on one or both sides, allowing for reduced minimum clearance. Now, let's focus on Section 110.26C, which is about entrance to and egress from working space. This subsection has multiple parts addressing different scenarios. Section 110.26 Code covers the general requirements for providing access and egress. It generally states that there must be at least one entrance to and egress from the required working space. It also dictates that the entrance cannot be blocked by fixed obstacles and should provide adequate access for personnel and equipment. Section 110.26C2, which is central to this discussion, specifically addresses large equipment. This section mandates that for equipment rated 1200 amps or more and over 6 feet wide that contains overcurrent devices, there shall be one entrance to and egress from the required working space that is at least 24 inches wide and 6.5 feet high at each end of the working space. This is where the two-door and panic hardware requirement comes into play. If the equipment meets the criteria of being rated 1200 amps or more, exceeding 6 feet in width, and containing overcurrent devices, it typically necessitates having two doors, one at each end of the working space, equipped with panic hardware for easy egress in case of an emergency. The rationale behind this requirement is to ensure that personnel working on or near large electrical equipment have a readily available exit path in the event of an arc flash or other electrical hazards. Panic hardware allows for quick and easy opening of the doors, even if personnel are wearing protective gear or are in a state of panic. However, it's essential to reiterate that the 1200 amp threshold refers to the equipment's rating, and in the case of a panel with a lower rated main breaker, this requirement may not be triggered. To further clarify this, consider the definition of equipment as used in the National Electrical Code. Equipment refers to a general term including material, fittings, devices, appliances, luminaires, apparatus, and the like used as a part of, or in connection with, an electrical installation. In the context of Section 110.26C2, equipment refers to the entire panel assembly, including its enclosure, bus bars, and overcurrent protection devices. Now consider a scenario where you have a 1200 amp rated panel but decide to install a main breaker with a low amperage rating, say 800 amps. In this situation, the panel itself is still rated for 1200 amps, but the overcurrent protection is limited to 800 amps. The question then becomes whether the 1200 amp rating of the panel necessitates the two-door and panic hardware requirement. Based on the interpretation and application of the National Electrical Code, the answer remains no. The critical factor is the rating of the overcurrent device installed, not the maximum rating of the panel itself. Therefore, if you have a 1200 amp rated panel with an 800 amp main breaker, you would not be required to have two doors and panic hardware as per section 110.26C2. It's essential to consult with local authorities having jurisdiction to confirm their interpretation of the code, as interpretations can vary. However, the general consensus is that the actual overcurrent protection rating is the determining factor. Let's look at a couple more examples to solidify this understanding. Example 1: a 1600 amp switchboard, meaning it's rated for 1600 amps, houses multiple overcurrent devices, including circuit breakers and fuses. In this case, the switchboard clearly exceeds the 1200 amp threshold, and it also contains overcurrent devices. Therefore, it would typically require two doors with panic hardware, provided it also exceeds the 6-foot width requirement. Example 2: a 1200 amp motor control center, often referred to as a motor control center, is used to control multiple motors in an industrial facility. The motor control center is rated for 1200 amps and contains numerous motor starters and circuit breakers. Again, since the motor control center is rated 1200 amps or more and contains overcurrent devices, it would generally require two doors with panic hardware, assuming it also meets the width criterion. Now let's briefly discuss the evolution of section 110.26C2 over time. The specific wording and requirements of this section may have changed in different editions of the National Electrical Code. The question mentioned that until 2005, it applied to large equipment. This suggests that there might have been a change in the code language or interpretation after 2005. It's crucial to consult the specific edition of the National Electrical Code that is in effect in your jurisdiction to ensure compliance. Code requirements can vary significantly from one edition to another, so staying up to date with the latest changes is essential for electrical professionals. In summary, when evaluating whether a panel or other electrical equipment requires two doors and panic hardware based on section 110.26C2 of the National Electrical Code, the primary consideration is the rating of the overcurrent devices installed, not simply the equipment's overall rating. If the equipment is rated 1200 amps or more and contains overcurrent devices, it will generally require two doors with panic hardware, provided it also exceeds the width requirement. However, if the equipment is rated for 1200 amps or more but has a main breaker or other overcurrent device with a lower amperage rating, the two-door and panic hardware requirement may not apply. Always consult with local authorities and refer to the latest edition of the National Electrical Code to ensure compliance with all applicable requirements. Now let's consider some practical implications of this understanding. Firstly, when designing electrical systems, it's essential to carefully select equipment and overcurrent protection devices to match the actual load requirements. Oversizing equipment can lead to unnecessary costs and may trigger code requirements that are not actually needed. For example, if a panel is only expected to carry a maximum load of 800 amps, there's no need to install a 1200 amp rated panel unless there's a clear expectation of future load growth. Secondly, when installing or modifying electrical equipment, it's crucial to verify the overcurrent protection rating and ensure that it's properly coordinated with the equipment's rating. Using a smaller breaker in a larger panel can be a cost-effective way to meet current load requirements while still providing room for future expansion. However, it's essential to ensure that the breaker is properly sized for the load and that it provides adequate protection against overloads and short circuits. Thirdly, when conducting electrical inspections, inspectors need to carefully evaluate the equipment's rating, the overcurrent protection rating, and the overall installation to ensure compliance with the National Electrical Code. This includes verifying that the required working space is provided, that access and egress are adequate, and that all equipment is properly labeled and maintained. Now let's briefly touch on some other related National Electrical Code sections that may be relevant to this discussion. Section 110.26 covers the general requirements for working space around electrical equipment. It specifies the minimum clearances required in front of the equipment, as well as the width and height of the working space. These clearances are essential for personnel to safely operate and maintain the equipment. Section 110.26b addresses the height of working space. It generally states that the working space shall be clear and extend from the grade, floor, or platform to the height specified in Section 110.26e. Section 110.26d covers illumination requirements. It mandates that sufficient illumination shall be provided to permit safe and effective work in the working space around electrical equipment. Adequate lighting is essential for personnel to properly inspect and maintain the equipment. Section 110.26e addresses dedicated equipment space. It requires that certain electrical equipment be installed in a dedicated space and not be located in bathrooms, toilet rooms, or similar areas. This is to ensure that the equipment is protected from moisture and other environmental hazards. Section 110.27 covers guarding of live parts. It requires that live parts operating at 50 volts or more shall be guarded against accidental contact. This can be achieved through enclosures, barriers, or other means. The purpose of guarding is to prevent electrical shock hazards to personnel. Let's now address a potential misunderstanding. Sometimes people assume that if a panel is labeled with a certain amperage rating, that rating automatically dictates all the code requirements associated with that amperage. However, as we've established, the National Electrical Code often focuses on the actual installed and operational components, such as the overcurrent device, rather than just the maximum potential of the enclosure. This distinction is critical for proper application of the code. Another important aspect to consider is the impact of arc flash studies on these requirements. An arc flash study is an analysis of the potential hazards associated with arc flash events in an electrical system. The results of an arc flash study can influence the selection of overcurrent protection devices and the implementation of safety measures. For example, if an arc flash study indicates that a particular panel has a high arc flash hazard level, additional safety measures such as remote racking systems or enhanced personal protective equipment might be required. In some cases, the results of an arc flash study could even justify installing 2 doors with panic hardware, even if the equipment doesn't strictly meet the requirements of Section 110.26c2. This is because the primary goal is always to ensure the safety of personnel working on or near electrical equipment. Furthermore, it's essential to remember that the National Electrical Code is a minimum standard. It sets the baseline requirements for electrical safety, but it doesn't necessarily represent the best possible practices. In many cases, it's prudent to exceed the minimum requirements of the code to enhance safety and reliability. For example, even if a panel doesn't strictly require 2 doors with panic hardware, it might still be a good idea to install them if there's a significant risk of arc flash or other electrical hazards. Finally, let's emphasize the importance of ongoing training and education for electrical professionals. The National Electrical Code is a complex and constantly evolving document. Staying up to date with the latest changes and best practices is essential for ensuring electrical safety and compliance. Electrical professionals should regularly attend training courses, read industry publications, and participate in professional organizations to stay informed and enhance their skills. To reiterate, the answer to the original question is no. The requirement for 2 doors and panic hardware is not solely based on the panel's rated amperage, but rather on the rating of the overcurrent device and whether the equipment contains overcurrent devices, and the equipment exceeds 6 feet in width. Always consult the latest version of the National Electrical Code and local amendments for specific requirements.